Welcome to the Explainer. Think about it. Every app on your phone, every website you visit, it all starts as just an idea. But how does it become a real working piece of software? Well, today we're going to peel back the layers on that whole journey, from the silicon chips that do the thinking all the way to the AI that's now helping us write the code.
At its very heart, every single computer program, whether it's a simple calculator or a giant online game, follows one fundamental principle. This is the absolute foundation for how computers solve any problem you throw at them. It's super simple, really. It takes some kind of input, it does something with it inside this kind of black box, and then it gives you an output. Think about a calculator. You input the numbers, the black box does the math, and the output is the answer. Easy, right? Our mission today is to pry open that black box and see exactly how the magic happens. All right, so let's start at the very bottom of the stack, the physical brain of the computer. Before a single line of code can even think about running, it needs hardware. And as you're about to see, not all of these brains are created equal.
Yeah, this visual just lays it all out perfectly. It shows the core difference between a CPU, that's the central processing unit, and a GPU, the graphics processing unit. The CPU on the left, think of it like having a few super smart engineers who can solve really complex problems, but they do them one at a time. The GPU on the right is more like a giant factory floor full of workers, each doing a simple, repetitive task all at the same time. A CPU is great for running your operating system, but a GPU is built for stuff like rendering video game graphics or training AI models.
So you can basically think of CPUs as the sprinters of the computing world. They're all about low latency, which is just a fancy way of saying their goal is to finish one single task as fast as possible. GPUs, on the other hand, are the marathon runners. Or maybe a better way to put it is a massive relay team. They are built for high throughput, which means processing thousands of smaller tasks all at once.
And here's the secret sauce to the CPU's speed. A huge part of the chip is just dedicated to cache, which is basically super fast memory right on the chip. All that space for L1, L2, and L3 cache lets the CPU grab the data it needs almost instantly. That's how it gets that low latency. A GPU, in contrast, basically sacrifices most of this cache space so it can pack in way more processing cores.
Okay, so we've got the hardware, but how in the world do we actually tell it what to do? Well, we need a language the machine can understand. And just like human languages, programming languages have evolved over time to become way more powerful and, frankly, a lot easier for us to use.
You know, when you're first starting out, programming can feel a lot like snapping puzzle pieces together. Languages like Scratch let you literally drag and drop blocks that represent commands. There's no complicated grammar or syntax to memorize. If the blocks fit together, your code works. It's a fantastic way to learn the logic without getting bogged down in the tiny details.
But for more control and raw performance, developers turn to text-based languages like C. This little snippet of code does a really simple thing. It just prints a hash symbol 3 times. But look how cryptic it is. You have to create a counter with int I equals 0. You have to manage curly braces, semicolons, and use weird commands like /n, which just means start a new line. It's incredibly powerful, but that learning curve is steep.
And that complexity is exactly why languages like Python have become so incredibly popular. I mean, look at this. It does the exact same thing, printing a hash symbol 3 times, but the code is so much cleaner. It reads almost like a plain English sentence. And that simplicity lets developers build things way faster, which is a huge reason why it's everywhere now.
But here's the thing. Writing all that code, even in a simple language like Python, can still be a slow, kind of repetitive process. And that's where the next big evolution is happening. Powerful AI assistants that are fundamentally changing how software gets built.
These AI-powered tools are basically like having a partner sitting right there with you in your code editor. They analyze what you're writing, predict what you're trying to do next, and can often write entire blocks of code for you automatically. It's pretty wild.
The 2 biggest players in this space right now are GitHub Copilot and Tab9, and they each kind of focus on different things. Copilot is really known for its flexibility. It integrates with tons of other apps and lets you choose from different AI models. Tab9, on the other hand, is really focused on privacy, even offering a 0 data retention option so your code never has to leave your computer.
But adopting these tools forces companies to ask some pretty critical questions. Are we locking ourselves into one company's ecosystem? And here's the big one. Where is our secret proprietary code being sent for processing? This is exactly why the ability to run these AI models locally on your own machines is becoming such a critical feature for businesses.
Okay, So let's pull back for a second. You've got the hardware, you've got the programming languages, you even have an AI assistant helping you write. But how do modern applications, I'm talking about a social network or a huge online store, how do they handle millions of users and just enormous amounts of data all at once? Well, the answer is the database. It's like a hyper-efficient digital library for all of an application's information. And today, there are two main philosophies for how to organize all that data.
On one side, you've got relational databases like PostgreSQL. You can think of them as these perfectly organized spreadsheets where every single piece of data fits into a strict row and column. This is perfect when you need things to be super consistent. It's why your bank uses them, to make sure your balance is always correct. On the other side are document databases like MongoDB. They're more like a filing cabinet, where each file can have its own unique structure. This gives you massive flexibility and makes it way easier to scale for unpredictable traffic, which is why your social media feed can load so fast.
And here's something cool. When you're building for massive scale, sometimes the textbook solution isn't the fastest one. For instance, every computer science student learns that a binary search is more efficient than a simple linear search. But as this quote points out, if you know your dataset is really small, just checking each item one by one can actually be faster. Real optimization isn't just about following rules, it's about deeply understanding the specific problem you're trying to solve.
So when you put it all together, from the physical silicon chip to the programming language and now to the AI coding assistant, the entire stack of technology we use to build software is constantly accelerating. Each layer is empowering developers to build bigger, faster, and smarter applications than ever before. It all leads to one really fascinating question. What impossible problems are we on the verge of solving next?